Any other questions? These are good questions. So, okay. All right, so the one thing I said I was definitely going to start the day off with, or on practice exam B, is problem 11. Okay. So let's say, I don't know, we've got some major concerns of steroid use in baseball in the past decade. A manufacturer claims, we could read this whole thing out, but let's just first start out identifying what we're given here. Okay. I want to switch my video over. So this might take 1 second. There we go. I'll blow this up. I'll make this the whole screen in just a second. But so the first thing we're told is the probability a drug test shows a positive result, given that the athlete is using steroids, is 0.95. So let's just start writing out what we know here. So the probability that given someone is using or uses steroids, the probability that the test shows a positive result, or you could kind of say that they are using, right? We're told that's 0.95. Okay? So one approach to this, and you may not always need to find these kind of complementary probabilities, but remember sometimes we said there's going to be pieces of information that we're not given that are missing, but we can determine what they are, right? So I'm going to leave a little space here, but we'll kind of identify the other two things. Then I'll come back and say what I would do if I was working through this from the beginning. So the next thing we're told is the probability it shows a positive result, given that the athlete is not using. So we've got given that they're not using, the probability that the test shows a positive result is what? 0.01. And then the final thing we're told is the probability that if we selected a player at random, the probability that they're I guess I'm going to change this real quick because this doesn't, we'll call this using, because that's what I'm going to be saying. I just know the way that I talk. So the probability that someone's using steroids there is 0.15. Okay. So those are the three things that we were given from this information. Okay. So one thing that we could do is anytime I'm given a probability, there's a complementary probability I could find. The easiest one to think about is if I know that the probability someone is using a steroid is 0.15, what's the probability that they're not using? Yeah, just 0.85, right? The two states of nature have to add up to 1. This is almost kind of like hidden behind there's like the complement rule, right? There's only two states of nature, so if this is event A, this has to be a complement, right? If I'm using is event A, I'm not using is the complement. Right? So we know those two things have to add up to 1, so we can figure out that one pretty easily. Now we may not need these probabilities for the questions asked in this practice exam, but there could be questions to ask where I might need some probabilities that wasn't directly given. So this was the idea that after let's assume that we start out and I just wrote down that first thing I was given. Okay? After I write that down, what might be a good practice, just so you have all the probabilities you could ever need, is that if we condition on the same state of nature, but look at the other outcome of the test, right? Well, given that someone's using, they either get a positive test result or they get a negative, right? It either shows that they're using or they're not, okay? So if we're conditioning on the same thing, the probability of the two outcomes of the test have to add up to 1. Right? There's only two possible things I can see on the test. Any example I give like this, like we're not doing anything where there's like an inconclusive test. Okay? So if this is 0.95, I know that this probability has to be 0.05, right? Pretty easy. Then we can do the same thing here, right? If we're going to kind of maybe keep these separate, I'll draw a line here, draw a line here. So once again, after I wrote this probability down, what I could have done is say, okay, well, look, I'm going to condition on the same thing that the person's not using, but look at the probability of the other outcome of the test, which would be that we see a negative test result. And if it helps to write out the word like positive and negative here, that's fine. I'm just kind of shorthanding. So we're conditioning on the same thing now. So someone who's not using, if the probability they get a positive test result is 0.01, what's the probability they see a negative test result? Right? 2 outcomes of the test, we're conditioning on the same state of nature, or think about it as we're looking at like the same individual. Those have to add up to 1 as well. Okay? Move this over here. Any questions on that? We haven't even gotten to the problem yet, but I'm just kind of, anything you could ever need to do on these next couple problems on an exam, this would give you all the information you could ever need. Okay? So let's go. We'll leave that up here down in the corner. Let's think about the very first thing that we're asked to find. So, got all these together, and then we're asked, what's the probability an athlete uses steroids and tests positive? Right? So we're going to go here, write out what we're looking for. Okay, so what's the probability that they're using, and the test comes back positive. Okay. So we're looking for the intersection of these two events. If we go to our formula sheet, scroll up here, we've got that the intersection of two events is simply the conditional probability times what I'm conditioning on. So I'm just going to write out this general equation in the context of my example. Right? So here we can think about is my A, here's my event B. Okay? So the intersection should be equal to the probability of B given A, so the probability that the test comes back positive, given that they're using, and then multiply by the probability of A, or the probability of what I'm conditioning on here, right? Notice the probability of what I'm conditioning on is A, so the probability that they're using. Well, once I write this out in the context of my example, I go back here, what's the probability that, given that they're using, that it comes back positive? Well, that was told to me just to be 0.95. And then what's the probability that they're using? We had that down here, was 0.15. Okay. Any questions on that? I know I kind of like put this back because I can't have this all on the same screen. So we just grab those from those earlier probabilities and plug those in, right? Easy as that. So we're going to get what? 0.0 or 0.8 something. No, 0.143. I'm thinking of the next one. So we get 0.143, and we're done, right? So, this question was a little bit easier once we kind of wrote everything out in the context of our example. Okay. Any questions on that one? You want to see something again, or? Is anybody else having problems on Zoom seeing me, the video? Okay. Try leaving and coming back in and see if that fixes it. Or maybe this will help. It's kind of showing you should be what's up on the video. Okay. Any other questions on that? Okay. Okay, awesome. Glad that worked. All right, so now we'll go to the next problem, which was, and kind of do the same sort of thing. I'll leave this up here so as I'm writing, you can kind of see. What's the probability an athlete is using steroids and test positive? Okay. So now what we're looking for is, what's the probability that someone is, what did I say? I actually might have said it wrong. What's the probability they're not using, and this test comes back positive, right? So just writing out what the problem is asking for. Okay? Well, it's the exact same thing we were doing before, right? We can think about this is my event A, this is my event B, right? And it's going to be using that same rule where we can look at the conditional probability times what we're conditioning on, okay? So now, just as a reminder, that highlighted formula is the one we're using. So A and B, right, is the probability of B given A. So the probability of the test coming back positive, given that there, right, our event A is not using. So we just, right, I'm really just writing out this equation I have highlighted in gray in the context of my example. Okay? And then I kind of didn't leave myself a lot of room here, so I apologize, but multiplied by the probability of A, well, my A here, or what I'm conditioning on, is that they're not using, okay? So we just wrote out this equation in the context of my example. I'll make this a little bit bigger so we can kind of see that now. Okay. Any questions on that so far? Yeah. Oh. Oh, sorry. Hold on. Should have said something. Let me go back so I can show you. You're good. You're good. So in class, you weren't able to see it. Let's see if this works. There we go. All right. So what I was doing there, here was the general form of the equation, right? The intersection of A and B, right? Which I just wrote down kind of what the problem stated. The probability someone's not using and they test positive. So once we have that probability written down, we go to our equation sheet. We've identified what RA and RB events are. So then I'm just writing it out, right? The probability of B given A, there's a general form of the equation. I'm writing it out in the context of my example. Then multiply by the probability of what I'm conditioning on, or my event A here, which I have over there. Okay? Yeah?
So what's the best way to determine what A and B?
I mean, I'm usually pretty kind, but, right, it doesn't really matter what we call these, right? The general form of the equation is calling them events A and B. And so I can just think about whatever's in this first category, right? When I'm asked for that probability, it said, what's the probability someone's not using and the test comes back positive? So I just wrote that down. I'll call whatever's in the first position A and whatever's in the second position B. It's as easy as that. You know? Right? They're just whatever our, whatever the example we're looking at is, kind of substitute in the names there. Is that cleared up? Okay. Any other questions up to that point? At this point, once we have it written down, we just go back. Okay, what's the probability that someone's not using, given that they're not using? Probably the test comes back positive. Well, given that they're not using, probably the test comes back positive we had was 0.01. And then what's the probability they're not using? I look here, it's all the way down here. Probably they're not using was 0.85, right? So we plug in the 0.85 there, which is going back to what we originally had and kind of plugging those probabilities in. And this is the one that should be what? 0.0085. Actually, sorry, 0.0085. And then if we round that, I think that the answers were rounded to the third decimal, if I'm recalling correctly. Yeah. All right, so we go down here. We had to round it at third decimal, so 0.0085 becomes 0.009. And then the one that we found previously was that 0.13. Okay. Any questions on that? So those two weren't terrible, right? I'd say the next one's a little bit more difficult, probably one of the more difficult questions on the exam. Okay. Let's knock something off. I'm going to need that, so that's a little pain. Come back. So we'll scroll down here, go to question 13. And it always starts out, let's write out what we're looking for. Okay. So given that the test comes back positive, what's the probability the athlete is not using or does not use? So here we've got a conditional probability. So given that the test comes back positive, what's the probability that they're not using? Okay, that's what we're looking for. Right? So the problem here is going to become, if I go to my formula sheet, okay, I have a conditional probability equation here, but that's going to be really just this is being rearranged. So if I want to find the conditional, it's the intersection divided by what I'm conditioning on. Well, the problem is, what am I conditioning on here? That the test comes back positive? If I go back to my original equations, I don't have just the probability that the test comes back positive, right? All I have are conditional probabilities of the test coming back positive. So the probability the test comes back positive is going to be composed of two groups: people who were using and it correctly identified as using, and people who weren't using and had this false positive, right? So I don't have just the probability of my event B, the probability that it just comes back positive without any other information. So, you know, these practice exams are written in a similar way to the exam, and it's probably a good point once you get to this point that if I'm looking for a conditional probability and I'm only given other conditional probabilities, I'm probably going to have to use this Bayes equation, right? And that was the scenario we had in this case. We were looking for a conditional probability, and the information that we were given, we only had information on kind of these conditional probabilities for the outcome of the test. So all I'm going to do, and I wish I could make what I'm writing a little bit bigger, because I do want to have kind of this pulled up, this general form, so you can kind of see me work through this, right? So I'm going to take this general form of the equation. Think about this is my S, and this is my event E. Okay? So I see a lot of you kind of have laps, so hopefully you can have the formula sheet of E. If you want to have it pulled up, I'm going to make this bigger so it's a little bit easier for me to see. But I'm basically just going to talk through this equation, right, and write it out in the context of our example. So the very first part of that Bayes equation is the probability of E given S, right? So the probability of E, the test comes back positive, given S, our S was that they were not using. And then it was multiplied by the probability of S, so the probability that they're not using, right? And that's what's in our numerator. So hopefully this doesn't screw us up too much in class here. But basically what I was doing there, okay, now we can see it. I just wrote out that numerator, oh, sorry, I wrote it out of order. I guess the probability of S should have been at the beginning, but it doesn't matter, right, what order we multiply things in. All I was doing was writing out this numerator in the context of my example. Now notice, the first part of the denominator here is the same as my numerator. So for the sake of just, when I'm writing this down, it's going to be the same thing. For the sake of just having enough room, I'm just going to say that, you know, this is the same thing as what we have in the numerator. If you want to write it all out, if you have enough room on, you know, kind of your notepad there, you would write out exactly what we have in the numerator as the first part of that denominator. And they're always going to be the same there, right? The form of the general form of the equation, those will always be the same, okay? So the second part is the probability of S complement, right? So if our S was that they're not using, what would S complement be? They are using, right? So S complement is that they are using. And then it was times the probability of E given S complement. Well, our E was that the test comes back positive. Our S complement, we just said, was that they were using. Okay? So once I have that Bayes theorem written out in the context of my example, it makes things a lot easier, because now it's just a matter of going back and plugging things in. Right? So what's the probability that they're not using here? Well, we had that earlier was 0.85. So we can kind of think about 0.85. Given that they're not using, what's the probability the test comes back positive? We are given that information, right? Given that they're not using, the probability the test comes back positive is 0.01. Now, the first part of that denominator is the same as the numerator, so I don't really have to keep going back. I know that It's going to be the exact same thing there. Okay. Now, what's the probability that they're using? Oops, sorry. Okay. So what's the probability that they're using? I go back. Well, probability they're using was 0.15. So plus 0.15 times. Given that they're not using, what's the probability the test comes back positive? Given that they're using, the probability the test comes back positive is 0.95. And now it should be kind of, right, that's a little bit easy. Now I just enter that into my calculator, okay? Any questions on any kind of part of that process? So anytime we're looking for this conditional probability, write it out, what you're looking for. Identify what your S and your E are. That way, you can kind of use that formula sheet equation to help you write it out in the context of your example. Once you have it written out in the context of your example, then it's just a matter of going back at those original probabilities and plugging in those values. Okay? Any questions on that? Okay, so this is probably one of the harder kind of questions on the exam. You will see one like this. Okay? So what does this end up being? This I should have my calculator pulled out here. I might have forgotten my office, but I think it ends up being what? This group is going to be larger. So if we go back here and look at the possible answers, if I recall, I think this is this one 0.056, I think. Yeah, if we work out that math, we enter that into our calculator. Okay. So if we compute this, it ends up being 0.056. Okay. Any other questions on that one? Okay. So I wrote the exam. So those of you, how many do we have here? Yeah, we got 15 people on Zoom and about, what, 10